Hello everyone, welcome to this video. I hope you're doing great. Now we are going to start with algebra, and our first topic will be polynomials. As you know, this is a good starting point, and we're going to use all the important things in polynomials. What does polynomial include? I hope you have covered number three with good understanding. So polynomial will include remainder theorem, factor theorem, roots. How do you find roots? Root coefficient relation, that's called VATAS formulae, and all these things. So mainly this. There will be another session on theory of equations, so that will deal with more of that. So presently we have these questions. Let's start with them. And I tried to bring this. We will have 6 questions, and among them, two will be single correct. Uh, Two will be multi-correct, and two will be subjective. All right. So I try to bring it like this, and I'll try to do this for all the sessions henceforth. Okay, the first question, without much further delay. Suppose all the roots of this equation are positive real numbers, then which of the following is true? So what do you see in this? You see that the quotient of x cube is -4 and quotient of the constant term is 1. So pause the video and try this. And I won't wait for you to pause it. Let's say alpha 1, alpha 2, alpha 3, alpha 4 are roots. Okay. That means what do we have? The root coefficient relation. Here we'll use that alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 is equal to 4 minus b by a, right? Minus 4. So that's not a problem. And then the product is 1. Alpha 1, alpha 2, alpha 3, alpha 4 is 1. Now, we know the sum, we know the product. Can we use AM-GM inequality? AM greater than or equal to GM implies summation alpha I by 4 is greater than or equal to fourth root of the product of alpha I. Okay. So this will imply that 4 by 4 is greater than or equal to 1, which means 1 is greater than. So basically, AM is equal to GM. Okay, AM is equal to GM. That will mean that all the roots are same, or all the terms are same. Alpha 1, alpha 2, alpha 3, alpha 4 are all equal. Now, we are able to do this only because the roots are positive real numbers, right? Positive real number roots are important. The moment we have all the roots same and the product of roots will be alpha power 4 equal to 1, and we are talking about real numbers, so alpha will be 1. So all the roots, all 4 roots are equal to 1. So first option is correct. And hence A will be, I think, 6 and B will be -4. So option C is wrong. Anyways, even if it was multi-correct, the roots, this is wrong, and no such choice of it. Obviously this is wrong. Okay. All right. That was a very good first question. Now pause the video and try this question. We have a polynomial p of x, and when this polynomial is divided by x minus a, x minus b, x minus c, it leaves the remainder a, b, c respectively, where a, b, c are distinct. That means p of a, so this is remainder theorem, by the way. Remainder theorem says p of a equals to a, p of b equals to b, p of c equals to c. That means p of x minus x has a, b, c as roots, right? P of x minus x equal to 0 has these 3 roots. So can I say that p of x minus x can be x minus a into x minus b into x minus c into some q of x? Right? Because these 3 are roots, so these 3 will be factors. Now this is factor theorem, implies x minus a, x minus b, x minus c will be factors. This is factor theorem. So remainder theorem, factor theorem, both utilized in one thing, in one single question. So can you see that p of x is x minus a, x minus b, x minus c q of x plus x. What do we need to find? We want the remainder when p of x is divided by this exact term. So obviously the remainder is x, right? If you divide with this is a divisor. This will be the quotient. This will be remainder. Clear? So I hope that was clear. I hope you paused the video. I didn't ask for that, but this was another good question. Now coming to multiple choice questions. Let p of x be a polynomial with integer coefficients such that p of 1 equals to 1, p of 2 equals to 2. Very good. Which of the following statements are necessarily true? So you can pause the video and try this out. First option is basically remainder theorem. Don't you think so? Yeah, because what is remainder theorem telling you? That when p of x is divided by x minus a, the remainder is p of a. That implies p of x is equal to x minus a into some q of x plus p of a. So p of x minus p of a is equal to x minus a into q of x. So basically x minus a always divides p of x minus p of a. So similarly, like it's simply a and b, x and a, same thing. A minus b always divides p of a minus p of b, right? And so first option is correct. Consequently, second option follows because 10 minus 5 should divide p of 10 minus p of 5. So the second option is correct. Can we say anything about the this thing 12? So okay, 5 minus 1 should divide p of 5 minus p of 1, p of 1 being 1. So 4 will divide p of 5 minus 1. That will imply p of 5 is congruent to 1 mod 4, right? Okay. And if I use, I only know about 5 minus 2 now, should divide p of 5 minus p of 2. And that will imply p of 5 is, and this is 2. This is 3. 3 divides p of 5 minus 2. And this will imply p of 5 is 2 mod 3. So that means p of 5 is not 1 mod 3. That implies these two together will tell me that p of 5 is not 1 mod 12, right? So if p of 5 is not 1 mod 12, option C is wrong. This is wrong. What about option D? 60, right? So let us first look at what is 60. 60 is 3 times 4 times 5. Yeah. So these three are GCD one thing. So I think I can now, if I individually find mod 3, mod 4, mod 5. Mod 5 is easy. What is that term exactly? What is that term? P of 10, this thing. Na? So let's see. Our term is P of 10 minus P of 5 minus 5. Obviously, 5 divides, 5 divides n. Hmm? Because 5 divides P of 10 minus P of 5. And that's good enough, right? What about 4? 4 should divide P of, okay, what is, let's do mod 4, right? Let's do mod 4. So if you look at 4 divides 8, so let me write something like 8 equals to 10 minus 2 divides P of 10 minus P of 2. Yeah. So that will imply that P of 10 is congruent to P of 2, which is 2 mod 4, because This is 4 divides this, so it's not a problem. We can write this as mod 4. Mod 8 and mod 4 won't make much difference here. So P of 10 is 2 mod 4. Okay. And what about P of 5? 4 divides 4 is equal to 5 minus 1, which divides P of 5 minus P of 1. So that will imply P of 5 is congruent to 1 mod 4. So what is P of 10 minus P of 5? That should be congruent to 1 mod 4 again, right? So that will imply that P of 10 minus P of 5, if I take minus 5, I'll just get minus 5. So this will be minus 4. So this is congruent to 0 mod 4. So this is not a problem. The term n is 0 mod 4. That means 4 divides. That's good. Now what about, what is the next one? Sorry, 3, right? So I want mod 3. So 3 you would get with 10 minus 1. So 3 would divide P of 10 minus P of 1, because 9 would divide this. That implies P of 10 is congruent to 1 mod 3. And similarly with 5, I can do 3 will divide. So 5 minus 2 equal to 3 will divide P of 5 minus P of 2. So that will imply P of 5 is congruent to 2 mod 3. So n equal to P of 10 minus P of 5 minus 5 is 1 minus 2 minus 5 mod 3, and that is minus 6 mod 3, which is congruent to 0 mod 3. So 3 also divides n. That implies 3 into 4 into 5 divides n. 60 divides n. Right? So 60 divides this term, no problem at all. So A, B, D are correct. Okay, these 3 are correct. And that was our first multiple choice question. Next. There's a second multiple choice question, correct question, multiple options can be correct. So check it out. Pause the video, try it out. Let P of x be polynomial with integer coefficients. Again, let A, B, C be 3 distinct integers with P of A, P of B, P of C equals to minus 1. Which of the following are correct? Okay, so first of all, again, if you look at it, P of x plus 1 equal to 0 for x equal to A, comma B, comma C. I'm extremely sorry about that. That shouldn't happen. Yeah, that the roots are A, B, C. Now, that implies that Q of x, which is defined to be P of x plus 1, will have x minus A, x minus B, x minus C as distinct factors. That is simply factor theorem. So the first thing is correct. The product, since these are distinct factors, the product will also divide this. So I can write actually that P of x plus 1 is equal to x minus A, x minus B, x minus C into some Q of x. Is that clear? This is like the second question which we saw. Now, using this, if P of k equal to 0, that will imply, if P of k equal to 0, k minus A, k minus B, k minus C into Q of k is equal to 1. That implies that k minus A, k minus C are 3 integer divisors of 1. 3 integer divisors, meaning these are integers, A, B, C are integers, right? And k is an integer. So k minus a, k minus b, k minus c, divide 1. What does that mean? That means each of these can be plus or minus 1. So here my problem is they are not distinct integer divisors, right? At most they can be 1 minus 1. 3 distinct is not possible. So B is not true in that sense only because it is written distinct. If it was written 3 integer divisors, I would have no problem with that. Distinct is not possible, right? And it has to be distinct because ABC are distinct. So these two together won't fit in. In fact, you can say that no integer roots is possible because of the exact same reason. Because, you know, since ABC are distinct, this will imply that k minus a, k minus b, k minus c are distinct. But they have to belong to this plus or minus 1 only. Only two values distributed among three. So at least two will be same, right? So this is not possible, which is not possible. Not possible. So two distinct is not possible. Three distinct is not possible. So it has no roots. That is not a solution. P must have degree exactly 3. Again false because obviously the degree of Q can be indefinite. Right? We cannot determine this. So it is also wrong. So only option A is correct. This is such a good question. Right? So I hope you found this interesting. Okay. Now we are into subjective problem solving. Look at this problem and of course try it out. So what do we say? Suppose, so this question says that it has non-negative coefficients, right? So our a1, a2 till an minus 1, these are all strictly positive. That means f of t is strictly positive for t greater than 0, but it has n real roots. So none of the roots are positive. That implies f of t equal to 0 implies t is negative. So all the roots are negative. So let's say, for the sake of this thing, let's say t equal to minus alpha 1, minus alpha 2, these things till minus alpha n are the roots. So I am also, in hindsight, assuming alpha i's are positive. Okay, alpha i's are strictly positive. And we want to prove something about f of 2. What do we know about these things? Another thing is, first of all, f of 0 is equal to 1. It is that the product of the roots is 1. So what is f of x, by the way? Since the leading coefficient is 1, na? T power n. So f of t, I can write it as product of t plus alpha I varies from 1 to n. So f of 0 is equal to product of alpha I varies from 1 to n, so that is equal to 1. So product of alpha I is 1. I want to find f of 2. What is f of 2? So I'll use this. Let's see what happens. So f of 2 is product of 2 plus alpha I. I varies from 1 to n. And I want to show that so I'll use some other color. This is greater than or equal to 3 times 3 power n. Sorry, this is greater than or equal to 3 power n. So it seems like enough to show 2 plus alpha I is greater than or equal to 3 or something. Is this enough? But is this possible? Can I show alpha I is greater than or equal to 1 or something? But we cannot do that. Can I do something else? 2 plus alpha I is greater than or equal to 3 times alpha I power something. Okay, if I show this now, I can take product and everything because product of alpha I is 1. Okay, so if I show this, this seems possible. This seems possible. I want 3, right? I want 3. So what can I do? Mm, if I take AM greater than or equal to GM, I'll get 2 plus alpha I by 2 is greater than or equal to root 2 alpha I and something. So that's not really helping, is it? Okay. So instead of that, if I take 1 plus 1 plus alpha I, 1 plus 1 plus alpha I, since alpha i's are also positive, by 3, this is greater than or equal to 1 into 1 into alpha I power 1 by 3. So 2 plus alpha I by 3 is greater than or equal to alpha I power 1 by 3. So that will imply 2 plus alpha I is greater than or equal to 3 into this. All right. So if I now take the product, so product over 2 plus alpha I varies from 1 to n, is greater than or equal to product of 3 into alpha I power 1 by 3. So that means this will be equal to 3 power n into product alpha I power 1 by 3. Now this is equal to 1. So obviously we got f of 2 is greater than or equal to 3 power n. This is such a beautiful question. Such a beautiful question. Lovely. Loved it. Now when is the equality possible, by the way? This is basically AMGM, right? So implies equality implies 1 equal to 1 equal to alpha I. That means all the roots are equal to 1, right? So that implies, so equality, so f of 2 equal to 3 power n implies f of t was basically 1 plus t whole power n, right? Okay. This question I'll be giving it to you as homework. All right. So this uses a bit of pigeonhole principle. So use this, and this is a very easy question, pigeonhole principle and number theory a little bit. This is a good homework question. And let me know in the comments. All right. So that's it for today. I hope you enjoyed this session. I loved it. Thank you so much for watching it. So guys, a quick announcement. If you're interested in this video, most probably you're interested in higher mathematics which is beyond the school syllabus, beyond even the JEE syllabus, right? So if you are such a person who enjoys higher level mathematics, we're bringing a course for you named Target Math. We know that there is full math mastery, but that covers the mathematics in general. But this batch will cover mathematics in a higher level. All right, if you are interested in that, this batch is for you. It will be starting from 21st of July, so hurry up. It's going to start soon. It will be taken by the great Chetan sir. I hope you all know him. Definitely you must be knowing him. Now, who is this batch for? This batch is for class 12 students. It's for droppers. It's for ISI aspirants mainly, CMI aspirants also mainly. Or if you are simply aspiring for JEE and if you want a stronger mathematics, because JEE mathematics may not be that uh, stimulating for a lot of students unless you're doing calculus or something, but this batch will dig deeper into all the topics which are required for mathematics. If you enjoy mathematics, this batch is going to help you. Now, what are the highlights of this batch? There will be more than 95 live sessions, 3 sessions a day, 3 p.m. to 4:30 p.m. again taken by Chetan sir. UGA plus UGP pattern practice tests. So because ISI and CMI require higher level mathematics, and their pattern is in general that's how they test, and that's why it is so good. You are going to be practicing in their pattern. Assignments every day after the session, Telegram group for discussions after the class, monthly progress report. This is constant in every batch. Now, a free bonus of ISI UGB mastery batch, right? If you're preparing for this, you'll also require preparation for UGB. If you know what UGB is, it is a subjective paper, 8 questions, 2 hours. So that mastery, writing a subjective solution is going to take some practice, and this batch is going to teach you that worth 1,000 rupees you're going to get for free if you take this batch before 21st July. Now, if you want to avail this price, please use the coupon code given below, and you can avail it only for 13,000 rupees. And remember, it is 95 plus sessions covering all of mathematics in depth. So, yes, this price is definitely worth it. So, please go check it out. Link will be in the description. Please go check it out. That's it. Take care. Tata. Don't forget the coupon code. Continue with the video.